Recording in progress.
Okay, guys, let's get started. So let's see. I'm gonna switch over to, nope. All right, so we're back on Scholar. So today we're gonna finish what we started on last week, right? We were talking about the vector space model and just taking raw data. So today you have a homework assignment due, right? Which is related to getting 3 websites. Yes. Okay, all right, so let me do that now. We have a homework assignment tonight. And so let me, before I forget. All right, so guys. All right, so let me create the Dropbox for this. So you can submit the assignment. And then we'll talk again, reminders of where we are in the semester. Okay, so this was the last homework. MNIST with, no, this one, right, WECA. Right, so this you've already submitted. So then we've covered traditional, right? We went over this, correct? The sklearn algorithms. We went over this. Do you guys remember? We haven't covered this. There's no homework. No, I'm not saying there's a homework, but we went over this, correct? Yeah? Huh? Briefly? Okay. All right. So I'll look it over again. And then data scraping. So this is the homework. So let's take a look. So find 3 websites and download their contents, clean and tokenize the data, then calculate the frequency of the most common terms. Look for insights about the websites given the most frequent terms, right? That's what we did. And then also find 3 RSS feeds and download their contents, clean and tokenize the data, then calculate the frequency of the most common terms, look for insights about the RSS feeds, and you're supposed to generate those graphs, right? Remember that? I gave you the code for that. So you can see that frequency distribution plots, all right? So you have to create and then dealing with HTML, process RSS feeds, we talked about tokenization. So this is under the topic data scraping. This is probably samples of the scripts. Yeah, so here it is dealing with HTML, tokenizing, processing RSS feeds, the same thing, basically. So I'll remove that one. And I'll add the link so that you guys can submit your assignment. So this is due tonight by 10 p.m. and it'll stay open until Wednesday. Done. Complete the assignment as indicated in the Word I get 3 websites and 3 RSS. Make sense? So this is the homework, as we had discussed. So the link is now created, and you can go ahead and submit. All right, so if you look in the semester, we're getting very close to the end of the semester at this point. We had our intro, data sets and features, tensors, torch linear regression, torch simple neural network, torch with SciFar 10, transformations and deep learning, midterm homework with MNIST, right? And we talked about the term project. I want to talk about this today again. Then I talked about performance metrics. Okay, talked about Weka as a very nice tool for machine learning that you should be aware of. And then data scraping. So in case I haven't covered traditional machine learning algorithms, I'm going to move it a little bit down to here. All right, and we'll see if we do a review of that. So basically, if you notice, we're pretty much getting very close to the end of the semester. Move this down also. Okay, so basically in the first half of the semester, we covered machine learning with PyTorch, classification. That's it, right? So we did a simple classification, examples all the way to SciFar 10 and then MNIST, right? Basically with images. Now the last part is, today I'm going to cover, so we covered that. Then we started covering a few other tools like Weka and then data scraping, right? Which is getting raw data from social media. So now this week, you're going to have a new homework assignment, which is Twitter. So remember, if you remember at the beginning of the semester, I asked you to get your accounts. So you should all have these accounts by now, developer accounts for Twitter. I'm not going to do a lecture on this, given that it's pretty much the same thing as the data scraping one. So it's getting data, in the data scraping one, we got data from HTML and RSS feeds. Now you're going to get data from Twitter using the Twitter API. So the code is provided here, right? So you can just, use these 2 scripts. So there's actually two different scripts. They're not the same script, okay? So the way it works is, and this will be your new assignment. So the way it works is that one script gets the metadata, another script gets the text of the tweets. Does that make sense? So the one that gets the text of the tweets is similar to the RSS and HTML. You're pretty much going to do the same thing, right? And then the one that gets the metadata, what does the metadata mean? It means it gets from Twitter, not text, not, this is my tweet and I said this and that, but instead it gets the things related to that tweet. So for instance, what are the things, what is metadata for tweets? Retweets, number of followers, number of likes, and that kind of thing. And that's going to give you data in an Excel type spreadsheet. And then you just have to analyze it. How you analyze it, that's up to you. Just do some histograms, do some pie charts, etc. Get some insight about them. Does that make sense, guys? And then for the second script, the one where you get the tweets, the actual text of the tweets, then you will do the same thing that you did for RSS and HTML. So you're going to create the plots, that frequency graph, and get some insight, as I said. Does this make sense? Clear? Questions? All right, now if we wanted to do more advanced machine learning with text, that's what we started doing last week, right? So remember last week I talked about how we can take any sentence or any tweet, anything that's grammatically correct, or grammatically written, natural language. And then there's 2 approaches to convert it into something that fits into machine learning algorithms. And that's going to be either the bag of words approach, or what was the other one that I mentioned last week? The other algorithm, word to vec. right? Now, I did say that Word2Vec is an advanced algorithm that is covered in the deep learning class. So it's not going to be covered in this class. So in this class, we're only going to look at bag of words approach. So if you notice, I started doing that last week, right? And I'm going to continue doing that today. So the goal is at some point, we're going to make that look like the images, like the image data. And then basically we have a tensor, and then we can feed that into our PyTorch script and perform some type of classification. Does that make sense? So that's it. This is what you have to do for the term project. Remember, for the term project, you have parts A and part B. What is part A? ADSB data, right? You should be looking at the ADSB data. Remember, that's in JSON format. So it's basically, you know, it's very simple. There's no text, there's no images. It's just like a CSV type of data, but in JSON. So you have to do, you have to work on that, find a problem that you want to do related to that, and, you know, analyze it somehow. Either unsupervised or supervised learning, some type of a classification. You already know how to, you will learn how to do unsupervised learning today, because we're going to cover that, you know, clustering basically. And then the second part B of the project is what? Taking some data, right, and now annotating. So it's got to be a little bit more, you know, it's got to be a data set that's smaller, but, you know, it gives you a little bit more flexibility. So anyway, so this is these are the two scripts. So let's look at the Word document. All right, as you can see here, let's read through it, okay? So it says, it's not a practical exam, so it's just a homework. Complete the following: Twitter API. You will need to create accounts with Twitter, and they will provide the tokens needed to connect. So you should all have this by now, hopefully. Basically, you're going to be creating text files for analysis from Twitter data, and the source file is in Brightspace, as I showed. You're going to do some Twitter searches, and the code is provided. And then you're going to pre-process the data. So those are you complete that, and then you have two problems. For this task, you can use the sample file provided, search 3 terms on Twitter, and download their contents into a text file. Clean the data, open the files in Excel, and run some general statistics. Look for insights about the search term given the statistics. All right, this is the one that I said, the first script that only gives you the metadata information. Got it? Number 2, use the search code provided by the instructor. Search 3 terms, hint, use these as labels on Twitter, and download the corresponding tweets. Clean and tokenize the data, then calculate the frequency of the most common terms. So this means do the plot, the plot that you did, just like you did for RSS and HTML. Look for insights about the search terms given the most frequent terms. Collect about 100 to 300 tweets for each term. Create a corpus using these tweets by applying your knowledge of the vector space model. Okay, so if you can see this problem too, it's kind of like your project, but smaller. Okay, so now you're going to collect the text, and you're going to try to create a corpus that you can use for machine learning. You're going to identify what the features are, what the samples are, what the labels are, etc. Using this corpus, perform supervised machine learning using Weka, and now I'll change this to PyTorch. Okay, so using Weka and PyTorch. Compare at least 3 algorithms. So I'll make a couple of changes here. Compare your results using the performance metrics, which you should know now how to use the performance metrics, and do feature ranking, which you can do in Weka. Does this make sense? Are there any questions about this assignment? All right, sounds like you guys understand. All right, I'm not hearing any. So that's the assignment for this week, okay? So this kind of brings together everything that you've done. It's probably a more complete problem now, you know, so make sure you do a good job. Again, a couple of things about the homework. Again, remember, you must always submit a Word document or PDF. don't put your report in the zip file. If you submit a zip file, put it separate. Okay, please. Make sure again that your homework does not look like anyone else's homework. Okay, be very, very careful with that. All right. And just do a good job. So ask questions now and make sure you do it correctly. Okay. All right. So that's the assignment. Let's look at. Let me add the link actually because I keep forgetting to do this. Twitter. All right, and this will be due on the 15th. And complete the attached Word document, the attached problems in the okay. This is gonna be due. It'll stay open until the 17th. Okay. So that's your homework. Let's take a look at the two scripts just real quick. All right, so it's this one. Right, so here we are in Twitter data. Okay, so we'll take a look at those in a sec. All right, so let's take a look at this one first. You guys can see it, right? So you got some libraries there. You'll have to, you should have gotten some tokens, etc., to set up your account. So you'll make the connection to the API. You have some functions in here. Okay. But basically, you don't really, hopefully, yeah, so this code, if you notice here, it should work, hopefully, without errors. You can try it out. But basically what it does is it generates a CSV file, right? An output CSV file, very much, remember when at the beginning of the semester we saw, okay, inputs that are images, inputs that are text, inputs that are CSV, right? So this fits into the CSV category. And you can see here, I provided 3 terms, right? So data science, analytics, Hadoop, right? You need to find 3 terms of your own, whatever you want, and then collect. Basically, each call to fetch samples will make 50 Twitter API calls. The limit is 180 API calls every 15 minutes. So Twitter throttles you because they sell their data, right? So they don't want to just share it. I think it'll just be the last time I checked from the last 7 days, right? And so you will collect this data in a CSV and then do the analysis. Does this make sense? Pretty easy, right? All right, so that's one script. Play with it. The other script is the text one. So let's take a look at that one. All right, so here you can see similar idea. You'll make the connection with the tokens that were provided for you, and then you're gonna do a search, right? And then you can see it even provides you, the code for the frequency plot and everything. So the idea now, notice this might be written in 2.7, so switch it over to 3. Okay, so you might, you need to do you'll need to research, but the code is as you can see pretty short. So, you know, it's the API has, if anything, the API has become a lot easier to use with time. You can see here I put in a term, Purdue, right? And so you can, you know, again, you need to put in 3 terms, whatever you want. You could, for instance, let's say that you were making a corpus of 3 labels, right? You know, the labels could be Ford, Toyota, Volvo, right? So 3 brands, those are the 3 classes, and now you have tweets for 3 classes. You see that? It's up to you. Or you could say Coca-Cola, Pepsi, and what's another one? I don't know. So, and you have 3 labels with their data. So you could build a corpus in this manner, right? You know, something else, politics, right? So you could say, you know, Democrat, Republican, Independent, and now you get tweets for each one. So the idea is, in any case, is that you could use those as the labels, and then you get the data, and then you can build a corpus if you wanted to. Got it? All right, so you can play with this. This is the one that gets you the tweets themselves. All right, the text, and it generates a frequency plot, basically. All right, so that's the second problem. Are there any questions? Follow the instructions in the Word document. I'll have to make a few modifications on it, but otherwise it was pretty much correct. Okay. So this assignment, the Twitter assignment, let's go back to Brightspace, is this module here, as I said, probably one of the most challenging, or not challenging, but just the most involved, right? Because this one covers the entire pipeline. You will go from non-existing data set, just scraping data off the internet, to performing machine learning with Weka, which is pretty easy, and with PyTorch itself. Today, the code that we're going to cover, hopefully, will show you guys how to do well, we already did this, actually. The bag of words approach, we already did this last Monday, where we took some sentences and converted them into features, the bag of words features. Today, we're just going to extend that concept a little bit more and tie it to unsupervised learning, what's the difference between supervised and unsupervised? The only difference? Labels. Very good. So the supervised will have no label. Supervised will have labels. Sorry. Unsupervised has no labels. But the clustering k-means algorithm will try to assign labels. If you tell it assign 3 labels, it'll assign 3 labels by clustering the data into 3 clusters. If you say 2 labels, you know, 2. So we'll learn that approach as well. So now you have 2 techniques that you can use to create a supervised learning corpus. One is, as I showed you with Twitter, find tweets of 3 labels, you know, Ford, Toyota, Volvo, right? Or whatever, you know, there's no limit to what you can think of. Or this second one where you have some data set with no labels, and then you just tell a clustering algorithm, give me the labels. Got it? Those are 2 quick ways of creating a corpus for supervised learning. All right. So basically, yeah. So you have this assignment due tonight, and then you have this assignment due a week from today. Okay. Unsupervised, that's the topic that we're going to cover today. So you can see I have a link to the code. You can find the code there, right? That's the code that we're going to cover today. And there are some slides in here. All right, so we'll get to those as well. But I'll go over this topic today. Now, before I start with the lecture today, I want to remind you again about the term project. So you should be working on this. Remember, I gave you the ADSB Exchange link. So today, before the end of class, I'm actually going to create the assignment now. And I'll be modifying this. Now, remember, the project will be due. This is term project. This is very important. I think this is worth 20% of your grade, right? So I'll be grading this as project A, 10 points, and project B, 10 points, okay? So term project, this is due. Your exam is this day, so probably presentations are on the 8th. So you need to submit your term project before the 10th, okay? Your report and everything. You'll do the presentations even before that. Okay, so I'm gonna. I'll give you until Saturday, and I'll just say project A, project B. So project A, use ADSB data, find a problem related to aviation or something, or to the data, and apply machine learning techniques to solve it. You guys understand it? It's pretty open-ended, right? So what I'm looking for here is, this is a large data set. This is real. This is like a real problem, right? Let's say that you were working somewhere. This is a real thing, right? They're interested in developing some product, right? Commercial product of some kind. And they're going to tell you there's all this data out here, ADSB, it's only been around for 2 years. Find something. Let's find something. So what do you need to do? You need to go into the site, read everything in that site, find out the format of the data. What are the variables? What does it represent? I can tell you right now, it's basically the transponder of every airplane flying around, and they're reporting digitally now. They used to report in an analog fashion through radio, and it was limited. Now it's digital. So it can be weather data that you could use for weather prediction. Imagine, never before has, a country maybe had this data, right? They've had, weather stations, they have satellites, they have weather stations on the ground, but never before did they have things in the air all over the United States reporting about weather patterns, for instance. So if you took all that data in the aggregate, it could be new insights that could be, make huge changes in physics or in the weather or whatever. Do you guys see that? It's a new data source that never existed before, right? And so you really don't know what's out there. Also for an airline, there might be some data there that they never had before, and they could use to save money or whatever. You guys understand that? And that's only now with airplanes. Eventually, it'll be drones, the drone industry. Do you have a question? Yes, sir.
Files, it says now, and there's a number, and I was wondering, I tried dividing it by like milliseconds and seconds.
Yes.
I couldn't come up with an actual time. Is that?
Oh, the timestamp you're talking about. Usually think about this. Usually those timestamps follow a standard format. So there might be a library that's able to read that format without you having to parse it manually. Does that make sense? That's a very problem of 30 years ago. So it's been solved quite nicely. And I'm pretty sure when they selected this, they selected some standard format. So you should be able to read it directly. Don't parse it manually. Does that make sense?
Yeah.
I don't know if you guys heard there was an attempt on the life of some president in some country recently with a drone. So I don't know if you guys saw that, but literally they attacked them with a drone. So you can see that this is now very real for, and that was probably amateur military. Imagine real military, what they're doing. So, I do think that the drone industry, will be here, and ADSB as a part of it or something similar will be very important, right? So that's why I want you to do a good project with this, right? But that requires digging into the data right now, right? You should be working. You've all formed your groups, right, of 2 or 3. You need to be working on that. I'm keeping it pretty open-ended. There's no real annotation, I don't think. My recommendation with project A is don't annotate it. Instead, use large amounts of data. Do you know what I mean? So that's what I want you to do. If I say annotate, I mean grab a piece of data and say, oh, this is label 1, this is label 2. Label. If you have to do that manually, how many of those could you do before the end of the semester? Not even 4,000. Yeah, you wouldn't be able to do it manually. Do you understand why I break it into part A and part B? It's because of this. Because if I told you to annotate it, you'd get 2,000. You know what I mean? And so the problem with that is, look at all the data that we have and we won't get to see it. So project A is not about annotation. It's just about using the data as is. Got it? So that's the idea. And so that's why I'm keeping it pretty open-ended. So use ADSB. So let's say use ADSB data, find a problem related to the data, weather or aviation, whatever you want. You have to read a little about it, right? So that's what I want to see your critical thinking, and apply machine learning techniques to solve it. And then do not annotate this data, but instead use as much as possible. Okay, so that's basically the idea. Got it? Now, project B is annotate a data set, or let's say find a data set or collect. So collect. Here, it's not about don't find any data sets. So you need to collect a data set e.g. scraping, Twitter, or from ADSB. Okay, so collect a data set. You need to annotate it somehow. So what that means, what does that imply? That your data set will be smaller. You'll be limited by the amount of time that you have between now and the end of the semester to annotate it. So this is the small data set. Do you understand? So maybe I'll put in parentheses here so it's clear. This is small data set. Because of the limit of annotation, this is, I'll put big data here, which means a lot of data. That's really the only difference. Okay, and so small data set. So collect a data set, scraping, Twitter, or ADSB, annotate it, and again, do the same thing as here, and apply machine learning techniques to solve it. So let's see. So actually, I should say here, define a problem, collect a data set, annotate it, and apply machine learning techniques to solve it. Does this make sense? So obviously, you always need to find a problem. Let's say, for instance, that you decide to do this one with HTML websites. Well, what the problem is, what are you trying to find out? Do you see that? Or from Twitter. I don't know. Maybe you're interested in sports, right? The NFL or baseball or international soccer, whatever it is, right? Find, cricket, I don't know, whatever sport is of interest to you, find out look it up, but it needs to be annotated. So obviously this will be a small data set. The other one will be big data. So is this clear enough, guys, that you understand? Now, one thing that's really important, I'll add this, provide performance metrics. And I'll say this over here, provide performance metrics. What does that mean? You need to provide accuracy, precision, recall, F measure, something that allows me to say, okay, you did a good job. So for instance, project B for sure, you're annotating it. It's a supervised learning problem. You have to have performance metrics of precision, recall, and F measure. Project A, it's a really large data set. You need to tell me what you're going to do. Maybe you're going to find one of the fields in the ADSB data that could be used as a label. Do you guys see that? And then it becomes a supervised learning problem. Give me a second. Today, we're going to cover unsupervised. Maybe you do a little bit of unsupervised. You still need to provide performance metrics in some way. Is this clear, guys? You need to tell me that your model is effective or not. And it's okay, like you don't have to get 99% accuracy, right? In fact, if you did, I would feel that you didn't do something right. I expect you to get bad results, but I expect you to get, what I need to see is some improvement where you got really bad and then you try to improve it a little bit and you got a little bit of performance. Is this clear? So it's, you know, that's it. That's what machine learning is. Yes, sir. I also provided, when we covered sklearn, there's a function in there that also calculates the metrics. So you can also use that in PyTorch, for instance. Do you see that? Does that answer your question? Okay, great. So, so let me say this before I lose it, actually. But it's very important that the term project is very clear for everyone, given that you have very limited amount of time left. So there you go. The link for ADSB Exchange is here. Okay, so you can click on that, remember. So are there any questions about the project? Clear for everyone? All right. I don't see any questions, so I expect good results for this. All right, we have basically just 2 lectures left after today. So if you notice here, today we're doing this lecture. So I've covered the project, I'll move it up. And then after that, I just have next week, we'll do a continuation of this one here and maybe wrap up some lectures. And then the last lecture will be reinforcement learning. So I'll cover that. We won't do a lab for this one. And then we'll have one more day or one more week before presentations. So during that, so the week before presentations, you have to have something about your project. Do you guys see that? I need to see, so the week before you do the class presentation, you will need to do some kind of a demo for me. Okay, so I see what you are doing and hopefully help you out before 1 week before you do your presentation. Is this clear? So that would be, write it down. That would be the week of, so presentations are going to be the 6th, right? So that's the week of the 6th are presentations. So that means that November 29th, that Monday, is when you need to do a demo to me before you do presentations on the week on December 6th and your final exam on the 13th. Reinforcement learning topic will be on the 22nd. And then today and the 15th of November, we're just going to wrap up this final topic. Okay. All right. So that's the plan. Hopefully I'm not seeing any questions. So hopefully everything is clear. All right. So let's go ahead then and switch over to here. So let's switch over to Scholar. All right, so I'm going to go ahead and open the last script that we were doing because that's the one that's going to help us to finish up. All right, so let's take a look at the environment. All right. Conda activate PyTorch. Pi 36. All right, so we're there. So now let's take a look at ITS 520, old 2021. So processing raw data, I believe that's where we were. Okay, so we've got two scripts. Get text from URL. So these were the scripts for getting HTML and RSS feeds. Okay. Now I believe we were working on the create via vector space model from text, right? You guys remember. So remember, if you want to feed something to PyTorch, work your way back, right? So you want to do, your code that you did for Cypher 10, for MNIST, you know how to process images. Great, you just need tensors for that. But now the problem is you've got data from other sources like CSV or text, right? So you need to make your way back. So you know that PyTorch takes a tensor of specific format, and that came from images. Now we need PyTorch to take a tensor, and that tensor needs to come from social media, right? So that's really the trick. So between the raw social media and the tensor that will feed into PyTorch neural network algorithms, we need to do some processing, right? And that's why, what we're calling the vector space model. So remember, two algorithms currently could be used, the bag of words approach or word2vec. As I said, word2vec is a topic for the deep learning class. So we're just going to focus on bag of words. Now, this though, however, helps us to look at unsupervised learning also in a very efficient way, because since we have raw data, we don't have labels either, right? So let's see how we can derive that as well. So let's go ahead then and open up the create VSM, right? So here we are. In this case, I'm just using sklearn just because I wanted to show you another tool. That was loud. So as I was saying, we were, you could do this with TensorFlow, with PyTorch, with other tools, NumPy itself. In this case, we're doing it with sklearn just to show you how that works. So let's first of all review this script, which is the one that we covered last week, and then we can basically finish it up. Right, so last week we saw that we had, sklearn. We introduced something called the count vectorizer from feature extraction.txt. This module is the one that does the bag of words approach for us. So we're not actually implementing the bag of words by ourselves. We're just using an algorithm that will do that for us very nicely. We don't have to calculate the frequencies, any of that. Here also we have used NumPy and pandas just to help us out a little bit with the formatting. Now, to keep this simple and more obvious, I have added 7 sentences here, right? 7 sentences, which are engineered really to kind of drive the point really well. If you notice, basically there's the first 5 kind of relate to data science in some way, and the last 2 relate to sports in some way. You guys, you're advanced AIs, right? So you can easily tell if you want to break this into 2 groups, you would do it like that. Hopefully the amazing thing to you is that a simple machine learning algorithm can actually do that, the same, come to the same conclusion. So this is under the category of BOW, or the bag of words approach. We performed basically last week a very simple analysis on how to do this, right? So we create a vectorizer from count vectorizer. We're going to remove stop words like the, and so on. We fit and transform it based on the examples, which are these 7 sentences, okay? And we create DTM, data frame or data model, whatever you want to call it. And then after that, we print out the features, which are basically, in this case, remember that each word becomes a column, right? And then you're just going to say if that column is present in the sentence and count it. So remember that the downside of word2vec, or sorry, not word2vec, of a bag of words approach is that it gives you a very sparse matrix. What that means is the matrix is going to be really large, right? Let's say you have 100,000 sentences and you have a vocabulary of 10,000 words. That's going to give you a matrix of 1,000 by 10,000, which is pretty large. And unfortunately, it's full of zeros, right? The majority, 95% of the data is zeros, right? But still, it works. Obviously, like I said, word2vec solves this problem very, very nicely, but we discussed that in the last lecture. So you can look at the videos from last week. All right, once we print out the labels, we can also print out the matrix in a nice format. Here we use Pandas data frame for that purpose. And that's basically the code that we covered last week. So let's go ahead and run it, and hopefully it should run. Right, and there it is. So we have 7 sentences and we selected 13 words. So it prints out a matrix. Our matrix is 17 by 13. We can see that here in that. And then we can see the sentences here, and then we can see the words that are present. So this is our vector space representation of it. Notice that some of them have a count of 2 because the word appears twice in there, like super, super cool. So it appears twice in the sentence. Is this clear, guys, so far? Okay, great. So this is, we're caught up now where we were. Okay, so now what we're gonna try to do is we are going to try to do a couple of new ideas, all right, new ideas. So one of the problems with dealing with a very large matrix, such as this one, 100,000 or 7 by 13 or 100,000 by 10,000, if we have a large, in a real problem, we have a large vocabulary, is that it consumes a lot of memory, and it may not be great. However, there are techniques out there called dimensionality reduction. We're not going to get into the algorithms of those, but basically, you can still use them without, as black boxes, without really looking at the algorithm. So there's, 2 techniques that are very useful for that, for dimensionality. Actually, there's basically, we can divide dimensionality reduction into 2 categories, which are transformation and feature selection. So feature selection just means, like you did in Weka, right? So you get a list of the most important features and then get rid of some, right? And just keep the ones that, because it ranks them. So the ones at the top, the highly ranked ones, maybe some get a value of 0 in the ranking, so you can discard those features. Make sense? So for instance, let's say that the word cool, for whatever reason, didn't do anything for this. We could just get rid of that column for every sentence. And then we reduced our dimensionality by 1. Another technique is what is called feature transformation, which is a linear mapping of the features. And what that means is that we will take all the features and transform them into a smaller set of features. Those other features will be completely different from the original ones. You see that? So that's the idea there. And the two techniques, the standard techniques for that are something called principal component analysis and another technique called singular value decomposition. Okay? You can, as I said, these two techniques you can just use as black boxes instead of, without understanding the algorithm. There's quite a bit of theory that goes into principal component analysis and also singular value decomposition. If you want to learn more about those algorithms, I recommend that you take ITS 365, which is the foundations of machine learning, where the algorithms for that will be covered. But in our class here, it's an applied class, so I'm just going to give you, the tools, right? So the techniques. And as I said, every module, every toolkit, TensorFlow, sklearn, Weka, PyTorch, all of them, they have their own version of those algorithms. All right, so let's go ahead and implement that in our script here, and then we'll see what happens. Okay. So the idea here is a lot of noises too. All right. So the idea here is I want to do dimensionality reduction, right? And again, remember, the idea is I have 7 by 13, and instead I want to transform my data set into 7 by 2. You see that? I'm gonna, from the 13 features, I'm gonna transform it into just 2 by using an algorithm, a statistical algorithm, and in particular, singular value decomposition for this one. Okay, so, but PCA has some similarities as well. So let's do that. So here, what we're going to need is we're going to need an algorithm called Truncated Svd. All right, so I'm going to go up here. And now I'm going to say from sklearn dot decomposition import truncated Svd. Okay, this is always a nice technique. Now, what's the downside? So you might say, well, we should always do this, right? Because I have a limited computer. I don't want to process a matrix that's 100,000 by 10,000 if I can process something that's 100 by 3, right? You would always want to do that. So you might say that's really great, but is there a downside? There is. When you do feature transformation, you could lose some information. Do you see that? Because what it's doing is it's transforming this into that. But to make that transformation, you might lose some data. So the technique actually incorporates a way of telling you how much information you were able to keep. Okay, so it might say, for instance, if you transform it to just 2, you still retain 80% of the information, statistically speaking. So you lost roughly 20%, but you know what? It makes it a lot faster. And by making it a lot faster, it's real and real time. And so, between having nothing and having something that's still 80% good, you might choose that. Does that make sense? All right, do you have a question? I mean, the technical term is dimensionality reduction. It's part of the pre-processing, I guess maybe you mean. It's just, as I said, the reasoning for it is It helps you with memory, helps the algorithm be faster, but you may lose information. But the algorithm may still work. So your accuracy, for instance, if you used all the data, could be, let's say, 80%, right? But if you use dimensionality reduction, it is now 75%. So you lost a little bit in accuracy, but hey, that's, you know, it's an hour faster in processing. So there's a trade-off, basically, as with everything in life, right? So any questions on it? All right, so let's see then. So I added it here. Now let's go ahead and try to implement it. And hopefully we'll be able to view it, and then that should make sense. All right, so we got the sentences, we've got the right, so let's go over here. So I should say using singular value decomposition. This is a math technique. It's actually very elegant. Okay. So it's like PCA. It'll create something, the principal components. And basically each new SVD component is a linear combination of all the words. So when I'm gonna hook up my tablet in the next half, and I'll show you what I mean by that. Okay, but it's intuitive actually how it works. So let's create an object. Let's call it dimensionality reduction. And we're gonna initiate it as truncated SVD. We're gonna specify that we only want 2 components. What this means is we're gonna take, in our example here, 13 features and map them to 2 features. Okay, that's what I'm doing. They're doing this transformation. I'm gonna lose some data, but should provide some data, some good results. So now I do the training, fit and transform. So I'm gonna say dr.fit transform on the data that I have in DTM. Remember, DTM is what holds currently my matrix that is 7 by 13. Got it? So I do that. And now let's do the same thing we did over here, this print statement. So just so that it looks nice, we're gonna do a pandas frame. Okay, we need to provide from DR, right, the object, we're going to specify that we want 2 components. Or the components, sorry. So the components. Because we trained the object here, right? So we fit and transform DTM. So we've got the components now in it. We set that we wanted 2, so they're there. Okay, so it's going to be components like that. And then we're just going to, for appearance sake, the same thing. So we're going to do index equal, in this case, index should be the sentences, just like before. So the rows. And then the columns will now be, let me think about it. Yeah, so we're gonna do, each document will now be a linear combination of the components. So it's, so this is actually DTM DR. Yeah, that's how it should be. So DTM DR. Okay, the index is correct. And then here we just have to specify the columns. So that's going to be columns equal, and we're just going to give it some names because we created 2 new columns or features, which are transformation of the original ones. Does that make sense, guys? So we can give them any name that we want. And the reason for that is those columns may actually have some meaning. That statistically speaking, the algorithm figured out some kind of a correspondence, figured out some kind of a correlation, but we don't know what it is. The algorithm did it. It could be something like what you guys said, data science and sports. You see that it starts to kind of try to do those things, but it just doesn't, we don't know. So the name that we're going to give it is just something like component. So I'm just going to say actually singular value decomposition 1, singular value decomposition 2. We just don't know. Okay. All right. So let's go ahead and try this. So I'm going to do Control X, Y. So if it works, all right, and it worked. Do you guys see what I was talking about? So before, my data set looks like this one, right? I took some sentences, some tweets, RSS, whatever, and I mapped them in a sparse matrix with zeros and ones. Then I applied a transformation, which is based on the singular value decomposition algorithm. It transformed the words, all the features, into just these 2 columns. So now, what does that mean? It's really important because now before you were feeding this to Weka, for instance, or PyTorch or sklearn or TensorFlow, right? A matrix that was 7 by 13. Now we can feed a matrix that looks like this, 7 by 2. Do you guys see that? We may have lost some data, but we can train it like this. So in terms of memory, in terms of speed, it's also not sparse anymore, if you look, which is also a nice thing, which could help deep learning algorithms to learn better. That's a possibility also. And so there are some advantages to it. So now the sentence machine learning is super fun, which was represented by this vector, is now represented by this vector. Got it? And so on. This sentence, I like football, is now represented by that vector. Just 2 features instead of 13 or 10,000. Got it? All right, so it sounds like you guys are getting it. Let's go back to the script then. Let me try. Just want to try this. Oh, it's already a NumPy array. All right, and there it is. So that's a transformation. Okay, so we took our data from the original larger space into a smaller space. So let's think a little bit about what else we can do. Let's see. Let's do an experiment. Let's see if we can't map. Let's see if we can map the components to the features. All right, so let's go back to the script. So I'm going to go over here, and I'm going to try to do print pd.data frame, right? Data frame. We're going to say dr.components, comma, and now we want to map index is going to be singular value decomposition. So SVD1 and SVD2. Okay. And we want to see if we can't map that columns equal vectorizer vectorizer.get feature names. So yeah, it's the same thing that we did before. So let's see if we can't map that like that. All right, there it is. So if you notice, this one is pretty intuitive because it tells you something very important. It tells you that singular value decomposition. I have an error. Right. So this last one, it tells you basically that all the words are a linear, SVD1 is a linear combination of all the words, and SVD2 is a linear combination of all the words. Do you guys see this? Guys? Right, so that's basically what's happening here is that to arrive at SVD1, we basically, it's almost like you can think of it as SVD1 is equal to cool times that plus data times that plus football times that plus fun times that and so on. Does that make sense? So I don't want to get so much into the algorithm, but that's the general idea. So when you say it's a linear combination, that's literally what it is. Okay. All right. So it gives you kind of that mapping, and then that's basically the intuition behind it. All right, so now let's go ahead. So we've looked at the data. So hopefully now you know, now you have a new tool that allows you to compress data, and you can do that for anything, right? Any features that you have can be compressed by using this approach. So let's now try. So let's go ahead and let's try to plot this data, right? So what do I mean by that? Let's go back to this data set. I have 7 by 13, right? So I have 7 sentences represented by 13 words. Everyone with me? And I ask you, go, and I just send you out, for a week as homework. And I tell you, plot this data set. Plot it. You know what I mean by plot, right? Create a graph. How would you plot it? Tell me. So I want to visualize a picture of that. So first of all, what would be the points in that vector space? What are the points? Say that again. Okay, but I mean in the picture, right? I asked you to draw a picture of that data set. It is 7 by 13. What would be the points in that picture? What would they represent? How many points would you have in that picture? You should be able to answer that. What are you visualizing? Not the words. Not for each word. Not in this matrix of 7 by 13. Each sentence would have a point. Remember how machine learning works in the vector space model. The rows are the samples, the columns are the features. Remember what I said, the features are the dimensions in the axes in the Cartesian plane. You remember that? So let's take a group of people, right? And you want to represent them by height, wealth, or salary, height, and number of stamps they collected last year. How many features is that for each person? Each of you, I think there's like 13 of you here, right? And I want to do an analysis of you by height, how many stamps you collected last year, and how many stuffed animals you have, whatever, right? So how many features is that? 3. How many people? 13. Therefore, there are how many samples? 13. What are the dimensions of that matrix? 13 by 3. Okay. You see that? You need to be very good at this. Okay. Now let's go back to this. We have rows and columns. The rows are the samples. They're the sentences. They're the tweets. Right? If you're collecting tweets of Toyotas, Hondas, and whatever, right? I like this Toyota. My favorite car is Honda, whatever, right? Do you see that? So the rows are the samples, the features are the columns. So if this matrix is 7 by 13, what are the points in the picture that you would generate? How many points? 7, right? 7 points because there's 7 sentences. How many axes will this vector space have? How many dimensions? 13, exactly, 13. Now, can you visualize a Cartesian plane that is of size that has 13 dimensions? No, right? Mathematically speaking, we can have infinite dimensions. The math holds, and we can perform all kinds of operations in higher dimensional spaces, but visualizing it is impossible. We're limited to 3 dimensions. We can visualize 1 dimension, 2 dimensions, and as far as 3 dimensions. Does this make sense? Questions? So what I'm telling you here is the following. I compressed the data from 7 by 13 to 7 by 2. I may have lost some data. Let's say I lost 20% of my information. But my question, can I graph this? Can I get a plot or a graph of this as is? What's your answer? Impossible, right? No. How about the data set when it's compressed? 7x2. Could I plot it? Yes? Yes. You see that now? There's another advantage. Although you don't get much from visualization when you have data like this, still you can with this approach. Okay? And so that's what we're going to do. We're going to take a 10-minute break. It's 3:22. But in the next second half of today, we are going to try to plot it and then start to get some insights into what's going on. Huh? What? I'm sorry. Just let me stop the recording, but we'll come back to this. I'll stop sharing. I'll stop the recording.